close, Rock. Okay, we're picking up today. We left off with our 5.4 lesson. You had the definite or the indefinite integral. So just to recap what we talked about the other day, if you have the integral of 2x dx, can anybody tell me what it is? X squared plus c. You must put the constant on the end. That's what we do for an indefinite integral. What we are going to review today, it's a good day because you already know how to do it. We're going to do the definite integral. Okay? So indefinite up here, no bounds. Definite down here, bounds. So you must come up with a numerical value. So try to give you ones that a little bit more challenging, ones to press you a little bit because your tests, the fact is your last test had ones I would consider kind of really straightforward, okay? We're going to look at a little bit more challenging ones. So I have the integral 2 to 1, 1 minus the cubed root of x over the root of x dx. Any thoughts? Split the fraction. Chris has the idea. I'm going to rewrite this, the integral 1 to 2 of 1 minus x to the 1/3 over x to the 1/2 dx. So that would be the integral 1 to 2. So I'm going to split this fraction of 1 over x to the 1/2, which is x to the negative 1/2, minus anybody x to the 1/3 over x to the 1/2. When you're dividing, what do you do to the exponents? Subtract them. So 1/3 minus 1/2, negative 1/6. So I have minus x to the negative 1/6 dx. What do I do now? Antiderivative. What's the antiderivative? X to the negative 1/2. So if I add 1, it would be x to the 1/2 divided by 1/2. And dividing by 1/2 is the same as multiplying by 2. So 2 roots of x. Minus, if you add 1 to negative 1/6, you get 5/6. If you divide by 5/6, it's the same as multiplying by 6/5. So x to the 5/6. Plug in 2. We get 2 roots of 2 minus 6 times 2 to the 5/6 power. 2 to the 5th, 32. So the 6th root of 32. And then I'm going to have to subtract. What do I do now? What do I plug in? 1. Plug in 1 and you get 2 6/5. Oh, thank you. Zane, was that your question? Thank you. I will clarify in the test if I want your answer in simplest radical form or if I want a decimal or what I'm looking for. In this situation, let's just come up with a decimal. Here's a 2 minus 6 times 2 to the 5 over 6. Divided by 5. minus 2 minus 6 over 5. I've got negative 0.1097. How could I check my answer? I could plug in the original in the calculator. I'm going to check that. I'm not feeling really confident. I got some giggles from the audience. All right, calculate number 7. I calculate lower limit 1, upper limit 2. Hey, what do you know? What I really wanted to see is, does the graph sit below the x-axis? And it does. If you take your window and you go, your y value from -1 to +1, that should give you a really good indication of, if the graph sits below the x-axis. And you can see that it does. So amounting to negative 0.1097 seems reasonable. Any questions for that first one? Okay, let's look at the second one. What do you want to do here? Yeah, so we're going to write this as integral -3, -1 for y minus 3y to the -2 dy. dy. Antiderivative 4y. 2y squared. Antiderivative of 3y to the -2. Be plus 3 over y, isn't it? Evaluated at -1 and -3. Do I plug in the -1 first or -3 first? -1, and you get 2 minus 3 minus, now plug in the -3, you get 18 minus 1, or -1 minus 17, which is -18. Again, we should see that that graph sits below the x-axis, and it does. Obviously, if I asked you to come up with a rational number for an answer there, you would have no problem. It isn't, but I thought that we would need more practice with some tricky radicals and exponents. Not that I didn't trust your mathematical expertise. What is this? Optional Monday? Optional Tuesday. Bye. It's been nice. Just many words. Okay, geniuses. What do we do for this one? So Katie and Alex have excellent ideas. Unfortunately, you're both are incorrect. 1 plus sine squared is not anything special. D1, I'm sorry. What's that? 1 plus sine squared, it would have to be 1 minus sine squared. 1 plus doesn't work in this situation. Krista, do you have a thought? Yep, split the fraction again. So watch what happens if I start. And you got to be willing to. So you guys are absolutely right. Kaylee, Alex, Katie, 100% correct to say, let's look for a substitution for 1 plus sine squared. That's the first place to look. But at some point, you need to realize the substitution will not work. A second option is to divide the fraction. So we have 1 divided by sine squared. What's 1 over sine? Cosecant. So 1 over sine squared is cosecant squared of theta. And then what's sine squared over sine squared? Plus 1. Now, a lot of people, when they look at this type of problem, they say, well, if I'm going to find the antiderivative of cosecant squared plus 1, maybe I should look for another substitution. You see the squared, you see the 1, you get really, really excited. That's not going to work. We just need to look at the antiderivative of cosecant squared on its own. What do you take the derivative of to get negative cosecant squared? Cotangent. So what do you take the derivative of to get positive cosecant squared? Negative cotangent. So the antiderivative is negative cotangent of theta. What's the antiderivative of 1? Theta. Evaluate it at pi over 4 and evaluate it at 0. Looks like we need to turn to the circle of life. Pi over 4, how many degrees? 45. So what is the terminal point? Root of 2 over 2, root of 2 over 2. Cotangent is x divided by y, correct? So what's the cotangent of pi over 4? 1. So I have negative 1 plus pi over 4 minus cotangent of 0. Again, I'm going to go to my terminal point right here. That has a location of 1, 0. Cotangent, is it y divided by x or x divided by y? X divided by y. What happens when you do x divided by y? It is undefined. Turns out, as we talked about before, that the fundamental theorem of calculus states that in order for fundamental theorem of calculus to even apply, the function must be continuous over the entire interval. Turns out that this function is not continuous over the entire interval. Okay? Think about it. What is the sign of 0? 0. And so if you look at this part here, 0, you would end up with 0 in the denominator, wouldn't you? And that causes a problem from the very beginning. Had I changed the problem instead of sine squared to be cosine squared, we could have gone through the same type of scenario. We'd have secant squared plus tangent squared, and work that way. It's hard to find the antiderivative of tangent squared, but you get the point? If you were to look at this graph, it would be discontinuous at 0. So therefore, fundamental theorem of calculus does not apply. We do not have a result. No. Yes? Pi over 4 is how many degrees? 45. You're going to have to take 180, and you're going to have to multiply it by, I'm sorry, you have to take pi over 4 and multiply it by 180 over pi. So when you convert from degrees to radians and back and forth, you multiply by 180 over pi. See the pi's cancel. I get 180 over 4, which is 45 degrees. Therefore, you have a 45, 45, 90 triangle. And a 45, 45, 90, we know that this is true. You take a side and multiply by the root of 2 in order to get the hypotenuse. Well, in the unit circle, the hypotenuse is always 1. So instead of multiplying by the root of 2, we divide by the root of 2. You get 1 over the root of 2. Multiply top and bottom by the root of 2, and we get the root of 2 over 2. So it actually, so that just tells us our terminal point. Now we want to actually evaluate cotangent. Cotangent is not the x value. It's not the y value. It is x divided by y. So if you take this value divided by that value, you get 1. It's negative because it says negative cotangent, so we get negative 1. Okay, last example. Yeah. This will require you to notice something. Good. Chris and Grace got it. Integral pi over 6, pi over 3. Got to just try stuff till you see something that works. Can't be afraid to just try. So I got cosine of theta over sine of theta. That's cotangent times sine of theta over 1 d theta. What happens? Sines cancel. Integral pi over 6, pi over 3, cosine of theta, d theta. What is the antiderivative of cosine? Positive sign. Evaluated, pi over 3, pi over 6. Go to the circle of life. 60 degrees. What's the terminal point for 60 degrees? And 1/2 root of 3 over 2 is the terminal point. So therefore, which is sine? Root of 3 over 2, it's the y value. Root of 3 over 2 minus. Now we have to do pi over 6. Pi over 6 is how many degrees? 30 degrees. Very good. Root of 3 over 2, 1/2. Just look at it. Think about it. Okay, anybody notice anything? Where's it discontinuous? Everybody agree it's discontinuous at 0? Does 0 lie between these two? So does the fundamental theorem of calculus apply? It does not. So I have a couple of those problems sitting in the midst of your worksheet. What do you have to be able to do? You have to be able to look at the graph and recognize, and I want to be clear, if you don't remember that that function looks like this, I understand. I want everybody to remember that that function looks like that. But if you don't, that's fine. But you should at least be able to look at this and say, oh yeah, it's discontinuous at 0. I think that that's pretty fair. Last one. What's the domain for this graph? It goes from, yeah, that graph is from 0 to infinity, right? So if you wanted to make sense of that, you'd have to talk about from 0 to 9. You couldn't do to -9, right? So again, you have to talk about values that the function is determined over. So keep that in mind. You got the rest of the time to work. Go.